right, let's see how you did on your sampling distributions for sample proportions. Okay, so remember that at first you need to identify in the problem contextually what's the population value, what is the claimed amount for the population. So in this case, they had claimed, or they were saying, that currently what we know of is 4% of blood recipients get infected. Okay, then they said, all right, well then we have this new treatment. We take a sample of 2,000, and 23 out of the 2,000 got infected. Okay, so then that was 0.012. So we want to know, okay, well, how did that 0.012 compare relative to what the past claim was? So we had found that if the current rate is at 4%. So if this middle part is 4% and all the samples are around 4%, then um, this is where all the samples would be centered. And here's our standard deviation. We would have that small of a standard deviation, okay? P times 1 minus P over 2,000. It's small because we had such a large sample size. All right. But what happened was the sample results that we got, and we could do our z-score from seeing how far this particular sample result we had, was more than 6 standard deviations away from the mean. This was more than 6 standard deviations away from where the data would be if it was truly centered at 0.04. Therefore, I don't think that with this new treatment, the data would really be centered around 0.04. That's what we're saying. So, holy moly. Okay, now when we get our z-score, remember we're doing our p hat minus true p over the standard deviation of p hats. Okay, so question, make sure we answer the question, because sometimes it wants probability, sometimes it's a discussion. So it says, does this result indicate that the true proportion of patients who contract hepatitis after this new treatment is less than 4%? Or could that result just be because of sampling variability? Explain. No, holy moly. Sampling variability would place our sample within 2 standard deviations of 4%, but it was over 6 standard deviations away. So I'm pretty much saying there ain't no way that, based on this, that the new treatment has centered around 4%. That new treatment has centered around something way lower than 4%. Okay. Next, we were talking about poverty level of children. 28% was that current poverty rate. And then they got a new sample. And the new sample they got was 31%. So does this indicate that has this poverty level in children increased? Definitely something we'll be interested in with the major changes that have been happening recently, this past year, especially with all the COVID and everything. So now we'll address, of course, the specific question we're wondering. But is this 31% a big deal? Or is it just sampling variability? Well, I know that the mean of all the samples would be located at 28%. So all the p hats, all the samples of 300 children that I could gather, a bunch of samples from around the United States, those would all be centered, and they would be centered around that 28%. Okay? If it's still at 20%. Now, but I get this sample at 0.31. Okay, well, that's just right here. That is only a little over 1 standard deviation above the mean. No biggie. So to me, that's just sampling variability. That is definitely just I happen to get that particular makeup of those 300 children. So now the question was about computed probability. What is the probability that at least 31% live? So basically it's asking me what proportion of samples will be at 31% or higher. So I wanted to know this area. Okay, so I norm CDF'd from that 1.15 all the way up to 99. And so about 12.5% of samples would show me getting at least, oh, this is wrong, this sample that shows at least 31% of children living in poverty. Okay, so this here would read 31% living in poverty. Okay, so let's see. I wrote FYI. This sample does not indicate unusual or give me reason to think the poverty rate overall has increased. I just happened to get that particular sample. Okay, next. Here we found that the current claimed rate of Hispanics in Parker County is 13%. Okay, so then we take a sample of 72 and we get, out of the 72 that were called to jury that day, 5 of the 72 were Hispanic. So that's only 6.9%. So my question is, whoa, is that making me think that the way they select jurors is unfair? Do I think they have a poor sampling of people that they're getting in for jury duty so that they're not representing the Hispanic community the same as it happens amongst the Parker County residences? So here we go. So then here's my, so it's 6.9%. And let me see how many standard deviations that is away. Well, I compute my standard deviation based on P, 1 minus P over N. And look, that sample was just 1.5 standard deviations below the mean. So although 6.9% seems low, a person does not have the right to come in and go, we want a mistrial. My Hispanic client is not getting a fair trial because there's not enough Hispanic jurors on the jury, in the jury pool. Okay, so that's sampling variability. That's just what happened to be chosen that day. So that sample is not particularly unusual. Just 1.5 standard deviations. It could happen because of sampling variability. It wouldn't give me reason to think the jury selection system is biased or unfair. Okay. All right, here we are talking about the proportion of fatally injured automobile drivers. So out of all of the drivers in an accident who died, what proportion of them were intoxicated? Okay. So currently, we were told that the current rate of death due to or because of intoxication or the intoxicated drivers was 77%. Well, Dallas County gets this sample, and this sample just had 43 out of 65. Well, that's 66%. So is that enough for me to say, woohoo, Dallas, awesome. Is this about Dallas? Okay, Dallas County, yes, you are awesome. Good job. You have lowered the intoxicated driver rate death due to that in your county. Or is it just because of sampling variability? Well, I do my math, and I would know all samples should be centered around 0.77 with this standard deviation. Okay, z-score, p hat minus true p over the standard deviation. And yay, that is more than 2 standard deviations below the mean. So Dallas County, awesome. Good job. It does appear that your results are due to something happening. They are not just sampling variability. You got an outlier low amount. So I think that maybe the whole curve is actually lower than for your county. Okay, all the samples are showing they're not centered around 77%. They're probably centered somewhere else. So yes, the sample results are unusual and would most likely not have been obtained if the true proportion of deaths, injured drivers who were intoxicated, fatally injured, was 77%. So it's probably less than that. All right, so what are you doing to make it so good? Let's see if we can't fix that in other counties. So here we have the city will gain notoriety if 8%, if as a healthy community, if between 13 and 17%. I don't know why it would be in between and not just completely above, but anyway. If it is known that 8% of all Americans, so all samples in the United States, would be centered, all proportions would be centered from city to city to city. Should be centered at 8%. Okay? We don't take a sample in this problem. We just straight up want to know what proportion of cities, what proportion of cities are going to be between 13% and 17%. So, I guess we just proceed as if our sample is just a sample of size 1. So I just take a look at what city has those individual proportions. Okay, so there we go. There's our standard deviation. So that tells me that about 5.4% of communities will get that distinction of being healthy community. All right. I hope that helped you understand your proportions better. Thank you.